Hello everyone, welcome to the presentation of our work, Document Image Shadow Remover Guided by Color-Aware Background. Document images are very common. Shadows are often visible in images when the light sources are blocked. The low brightness in shadow regions reduces the quality and readability of the image, resulting in illegible content and unpleasant user experience. In this paper, we propose a new method to remove shadows in the image and restore a clear image without changing the content information of the image. Although natural image shadow removal has made substantial progress, these approaches generally perform poorly on document images. There are two main reasons. First, document images have drastically different features from natural images. Second, these methods do not consider the particular properties of the document image. Several document image shadow removal methods are currently available. These methods often estimate a constant background for shadow removal. However, the constant background is the color of the paper, which ignores the printer colors. This may provide inaccurate information for the shadow removal task, resulting in unsatisfactory results. To address this problem, we propose a color-aware background extraction network to extract a spatially varying background, which can preserve various background colors of the original image. The spatially varying background can provide more useful color information, contributing to desirable shadow removal result. We adopted the UNet structure to implement our CBNet. To train our CBNet, we employ a background calculator with local-to-global strategy to contrast the ground truth background as the supervisor. The background calculator first estimates a local background. Then, we refine the local background and get a desired ground truth background for the image. We can use the pre-trained CBNet to extract a spatially varying color background for a shadow image. Then, we propose a background-guided shadow remover network exploiting the background image as supplementary information. BG ShadowNet is our task network, which includes two stages. A discriminator is stacked at the end to distinguish whether the produced image is real or not. At stage 1, besides an image encoder, a background constraint decoder is introduced to produce a cross-shadow removal result, which combines the background features helping to promote the realistic cross-shadow removal result. Stage 2 embeds a background-based attention module and a detail enhancement module into the encoder-decoder network and is used to improve the cross result and produce the final shadow-free image. The background-based attention module in the network aims to eliminate the illumination and color inconsistency in the image by using the attention mechanism. The detail enhancement module aims to enhance the detail features at low-level scales. Our DE module consists of two parts: feature counting to obtain the statistical information for low-level features, and feature equalization to enhance texture details of low-level layers. In our experiments, CBNet and BG ShadowNet are trained separately. We first train CBNet using the background reconstruction loss as the constraint. Next, we fix the CBNet and train BG ShadowNet using 3 losses as the constraint. We also construct a new dataset comprised of real document images to facilitate the performance of document image shadow removal, which is the first large-scale real document dataset for shadow removal to the best of our knowledge. This page provides some visual comparison results. From these results, we can see that our results are similar to the ground truth. Here's another set of comparison results. From these results, we can see that results recovered by our method looked more natural and have little artifacts. This table concludes the quantitative comparison results. From the table, we can observe that our method achieves the best values for all metrics among all the comparing methods, clearly demonstrating the effectiveness of our method. We perform ablation experiments using 6 variants for our BG shadow net. This table summarizes the quantitative results. From the table, we can observe that the components embedded in the 2 stages can improve the shadow removal results. We also provide some qualitative results, which show that our BG shadow net with all the components can produce more realistic results. Finally, we summarize the article briefly. First, we constructed a new dataset RDD for shadow removal. Then, we propose a CBE net to extract a spatially varying background. At last, we propose a BG shadow net to remove shadows in the image. Thanks for watching.